Hey everyone, thank you for joining us today for our technical meetup event focused on scaling iOS development. We are all very excited to be here because this is our first virtual meetup that is specific for iOS. My name is Yamada and I will be your host today. I'm a senior engineer manager at DoorDash's headquarters in San Francisco and currently lead two teams that contribute to iOS. The first team is a full stack product team that is responsible for shopping and checkout experience on our apps. And the second team is a platform team that focuses on performance and quality across iOS, Android, and web apps. In today's event, our engineers will give a series of tech talks to showcase what we are doing to improve development quality and velocity of our iOS apps. We will dive into topics such as what we learned from being an early adopter of SwiftUI, how we evaluate Apple's new M1 chips with respect to improving developer efficiencies, how we are modularizing our code base to reduce build time, and how we are leveraging CI/CD for iOS at DoorDash. At the end of this presentation, we'll have a panelist discussion and a QA session. So please use the QA feature on Zoom to drop your question, and we'll do our best to answer them through Zoom or during the live QA session. To get us started, here's a quick overview of the iOS engineering at DoorDash. We currently have two native iOS apps, one for our customers who shop at DoorDash and another to guide our Dashers to deliver the goods. When we acquired Caviar in 2019, we invested in a rewrite of consumer apps so that we can power both apps through one code base. Since joining the company 2 years ago, we've tripled our iOS engineering team, and we are now nearing 100 engineers. Lastly, DoorDash is known as one of the early adopters of latest iOS technologies, such as SwiftUI and Combine, which comes with its own pros and cons. So we'll share some of that learnings today. Before we dive into tech talks, I would like to highlight that DoorDash is actively hiring iOS engineers across 10+ locations, including full remote roles. So if you're interested in any of the topics we present today, or would like to learn more about our latest product initiatives, please check out our career website at careers.doordash.com. And with that, I will now pass the mic over to Cary, who will share our learnings on SwiftUI.
Hello, mic check. React thumbs up if you guys can hear me. All right, sounds good. Hi, everyone. Thanks, Mr. Ray, for handing the mic to me. And I guess I'll do a little quick introduction first. For those of you who do not know me, my name is Cary. I am an engineer at DoorDash. I've been here about 8 months and counting at this point, and so far I'm loving it, mostly because we use a ton of SwiftUI and all the cutting edge stuff. So today we're going to talk about our experience at DoorDash, going over all of the SwiftUI bits. So for starters, well, we do live on the cutting edge, and many of you are probably old enough or were around when SwiftUI was first introduced back in 2019. It hasn't even been a full 3 years just yet, but DoorDash was not shy to adopt this like within 6 months of its release. We started this adoption back in 2020, and most of our app at this point is about 70 to 80% in SwiftUI, and we've rewritten almost everything by now, and we're getting closer and closer to the 90% goal. Next slide, please. And let's talk about the good stuff first. And welcome, everything is obviously fine on the surface. It is until we get deeper into this picture. All right, next slide. Positive adoption rate. So many of you guys probably remember back in iOS 13, SwiftUI was, to say the least, very hard to use. It wasn't until iOS 14, aka SwiftUI 2.0, that we started having like a lot of different features that truly bridged the gap between UIKit and SwiftUI. And as such, DoorDash was not shy about dropping iOS 13 as soon as possible. So as we can see here, this is pretty recent data from this particular week. We actually have about 96% of the users like across the board using iOS 14 and up. Let's zoom in on that little upper right corner a little bit, yeah? Yeah, okay, let's look at the percentage breakdown. So iOS 15 alone has already over 84% of our users. So this is fantastic. And this is data from Mixpanel. So it's like anyone who uses the Mixpanel analytics framework. Apple also publishes data on this, but they do it every like half a year or so. So this is the most recent data, and we're happy to have migrated to SwiftUI because almost none of our users got left behind. Next slide. So SwiftUI naturally has some advantages over UIKit. On the left side, we have rapid development. So building views in SwiftUI is such a breeze and it's super fast, right? Especially when you got a little preview panel on the right. And additionally, I'm sure we've all seen how fast SwiftUI can be when we're building out basic components such as the UI table view or the UI collection view, right? So these have been replaced by lazy stacks as well as grid systems in SwiftUI respectively. In addition to that, we also have amazing integration with Combine. For disclaimer purposes, only the published property wrapper here is actually part of Combine. Everything else are just convenience methods that Apple has given us so that SwiftUI feels like it's integrated deeply into the Combine ecosystem. Now for state, binding, and publish, this allows us to kick off these values and we can observe them if we choose to, and state object and observed object do exactly the same thing. We've also gotten the added bonus of event listeners, such as the .onChange modifier, as well as a few other ones. I think there's like onReceive as well, but be careful not to overuse this. There's a little bit more on this later. The .task APIs from async and wait has also been great, but keep in mind that this is only for iOS 15 and over. So we'll probably be adopting that very soon. Previewing stuff in SwiftUI is fantastic. I put this meme in here because it feels like the code and the canvas have finally joined in one piece. So any change that you reflect and make inside of one will be reflected in the other, much like a mirror. Next slide. So on the right side, you'll see an example of me trying to showcase a SwiftUI inspector in the code and doing the exact same thing on the canvas. And the real-time feedback has been very, very useful, and having the preview system to like check out the view that we're actually building without running the app, compiling the whole app, and then navigating to that particular view has sped up development substantially. Let's take a look at another benefit of SwiftUI over at the next slide. View modifiers, they are amazing. And we use them for pretty much everything, but the most commonly used ones up first is the modal. And we use it for modals of all sorts. My colleague Zoltan will be doing a little bit of a deep dive in the lightning talk after my session. But over here, you can see that we have a modal that covers like a third of the screen and the other 2/3 is kind of grayed out. But we only need one line to summon this modal for a product engineer, which is fantastic. Additionally, in the following example, you can see that we also use a lot of loading states that are custom. Here is an example of like the store page where you have a banner, some newspaper, I guess, dummy content, but that not every view has to have a banner. So you get to choose, and like they can choose which newspaper article scaffolds that you want. Last but not least, we also use view modifiers for all of our text theming. So we call it the text styles API. And you can see that we're scrolling through the entirety of the DoorDash fonts, lines, spacing, kerning, right? Every single feature that you can modify on a text, we have that covered. And for a product engineer, configuring your text is as easy as putting a line or two of code in. All right, let's visit another benefit of SwiftUI over in the next slide. Here we have the bad stuff. Okay, so the bad stuff is yellow because this is actually not the worst, right? It's things that make you go, this is very interesting. Makes you rub your chin a little bit. Let's look at our first contender of the bad stuff. And here we have the view debugger. So for those of you who come from a UIKit background, you're probably no stranger to this. We've seen the view debugger in SwiftUI is not very, very helpful. I am hopeful that Apple is going to fix this later because right now it just looks like your iPhone with too many screen protectors like kind of jammed on top. These things happen because SwiftUI doesn't have the classic design of like, hey, let's just make everything a reference type class, and we no longer use UI views and UI view controllers, but everything is a struct that is allocated on the stack, swapped in and out really quickly. So this is hard to use, but hopefully it'll get fixed later. Let's go to the next slide. We also have some missing pieces of the puzzle. So the first bullet, we have the webpage of goshdarnswiftui.com. Other prefixes that are not gosh darn also work for those of you who are familiar with this, but a lot of features from UIKit did not initially get ported over into SwiftUI, especially in iOS 13. So thankfully, in iOS 14, we've gotten a lot of the new features such as lazy stacks, grids, right? On the right, you can see the date picker as well as the color picker that we didn't have in UIKit have been brought over to SwiftUI. The progress view is basically the replacement for the activity indicator. So you no longer have to have your custom loading spinners. And last but not least, the full screen cover. I don't know how SwiftUI in iOS 13 worked without having the ability to present a full screen modal, but since iOS 14, that has been answered. Thank you, Apple. Now, if you have things that you absolutely need to fall back to UIKit, you can also do that using one of these representable protocols. So either UI view or UI view controller representable. However, if you are using UIKit for the most part and just want to experiment with SwiftUI, you're welcome to use the UI hosting controller to present one or two views in SwiftUI. So it kind of goes back and forth really, really easily. Next slide, please. Navigation link. So this is a pretty contentious point in regards to SwiftUI, but SwiftUI hasn't made navigation easy, to say the least. On the left side, we have the whole topic of lazily loading navigation destinations. So in iOS 13, this was actually a huge issue. So this is kind of a navigation leak where if you had say a list of items, right, and you wanted to select one of these items, well, the destination view would have been already loaded in memory unless you wrapped it inside of a lazy view, right? So this was a huge memory leak and it affected performance, and people were like, hey, what the heck, Apple, can you fix this? So at DoorDash, we had to make a separate in-house solution that is similar to the one you find over Stack Overflow. So let's look at the code snippet real quick. So over here, we actually wrapped it inside of a background, but for now, let's just focus on the part where it says lazy view. You can find this code over at the link that I have provided at the top. Now, on the right side, we also have programmatically pushing a view, right? So navigation link, unfortunately, when it's contained inside of a list, it's going to start styling your content as well. So we ended up having to use like empty views, right? And by styling the content, I mean, it'll change your text color, it'll add a little chevron on the right, but sometimes you might not want all of that stuff. So we use empty views or just these empty view instantiated classes to basically ignore all of the theming, and that's similar to what we see on the left code snippet. We also use a binding to programmatically activate a navigation link, and because we don't like to repeat ourselves too often, we've also created a convenience function, as you see in this code snippet, to make it as easy as possible, right? So for the most part, we've wrapped all of this inside of the background and then just said, hey, we have a navigation link, bam, here's the destination, when should it be active? That's it. We've made it as simple as possible. All right, next slide, please. Status bar and navigation bars. All right, so a couple things in SwiftUI. Status bars are not modifiable at all. So you can no longer change whether you want a light or dark background for the status bar. However, navigation bars also lack a lot of color options. So you're either forced to fall back to UIKit or use the dot appearance to change the color across the entire application. So if we go to the next slide, we can see an example of how DoorDash does it through this code snippet. We actually use appearance to modify our navigation bar across the entire app. Thankfully, we only have one navigation bar color, so it makes it easy. And in the next code snippet, we can see that we want this to be applied throughout any subview that's contained inside of navigation as well. Let's go to the next slide and take a look at text field and text editors. So these things were actually pretty lacking in SwiftUI as well, but less lacking than the whole navigation bar situation. So for starters, you're missing a couple of things. The first being you cannot format a text inside of a text view. I guess in SwiftUI, it's called the text editor, but in UIKit, you could modify the placeholder, the text that you had inside of the text view. Yeah, don't have that liberty in SwiftUI. You also cannot show a text field inside of an alert, which sometimes you might need to do. So for these things, you might have to, well, definitely have to fall back to UIKit. The second bullet talks about the first responder issue. We didn't really have an API that exposed this in SwiftUI. So if you wanted to keep track of which text field the user is currently editing or like hop them over to the next or previous text field, it was kind of hard to do. But thankfully, Apple introduced a focus state as well as the focused function where you have to pass in the focus state variable in iOS 15 and over. So we're looking forward to using that instead of our current approach. Next slide, please. The last but not least, we have the on-change palooza. I actually wrote a lot of this code in this snippet, but the on-change modifier allows you to really listen in on any sort of state change that you have access to. And in this case, I have like 7 or 8 different on changes. This is a huge problem if you're touching shared state. If you're modifying shared state, be careful about like having so many on changes that touches the same thing, because with great power comes great responsibility. Just a heads up. Next slide, please. Now we're gonna look at some of the really, really bad stuff. And for the most part, this is fine, right? Like I said, it's always great over the hood. Under the hood, it gets a little bit sketchy. Let's hit it with our first contender, scroll views. Okay, scroll views in UIKit. If you look at the documentation, right, it's like 6, maybe 5 pages. But if you look at the documentation for Swift UI, it barely covers 1 page. So off the bat, you already know that UIKit is a lot more powerful and exposes a ton more customization for the developer. Next slide, please. Scroll views in UIKit definitely had a lot more APIs. So UI scroll view was amazing. At DoorDash, because Swift UI didn't have as many criteria and APIs as the UIKit version, we had to create our own wrapper. And by we, I do mean my colleague Zoltan. He led this whole effort. So ask him if you have any good questions. Swift UI scroll views now in the DoorDash format support content offset and content height. And we also have closures for when the acceleration, decelerations happen. And most importantly, I thought this was a pretty basic one to including the Swift UI version of scroll view, but enable and disabling it was not allowed, but now we have created the wrapper to support that too. The first example, we also have some bonus features such as snapping support. So as we're going through this carousel of amazing Korean food, you can see that we never snap with like an image where it's in the middle, right? Everything snaps to the edge as its preferred location. In the other example, we've also added a bunch of page indicators, and this is very similar to a page view controller that you had in UIKit. Next slide, please. So scroll views, just a couple more examples. I'm going to keep this one short, but to scroll or not to scroll is like a really hard question to answer. Let's look at our first example. Here we have a modal, right? We can drag the modal down, the entire thing, right? You can move up and down to dismiss and everything. But we also need the specific requirement of scrolling through the content, as you can see here. To differentiate that, we need to know the content offset to see if it's at the top and then start scrolling the content. In the next example, this is not limited to just modals, right? We also have the bottom sheet. The bottom sheet needs to drag and move with the cursor, but it also needs to support content scrolling as well. And to differentiate this was basically the same concept, but we would not be able to do this without Zoltan's custom anchored scroll view, so to speak. Last but not least, to wrap it all up, Swift UI is imperfect, but for the most part, it actually works really well. Like it works when it does. So for that reason, I've kind of provided an analogy that Swift UI is like a sports car, right? It's fast, it's declarative coding style, it's really easy to read, real-time feedback through Campus is amazing, and it works well when it does, right? Just kind of like under the right conditions, a sports car will go super fast, but it definitely lacks a lot of features, some of which require custom development, and UIKit is kind of like your family Honda CRV, right? It has amazing mileage, has all the features, always dependable, great for falling back in case you're in need. And the only drawbacks to UIKit are that it's a little bit slower than Swift UI, but it's also imperative encoding style and it doesn't have real time, but it's always gonna work. And with that in mind, let's do a little bit of a case study for modals. And I'm gonna hand off the mic to Zoltan.
Thank you very much. So my name is Zoltan and I've been with DoorDash for 5 years now. And but my past 2.5 years, I've spent with Swift UI. I work on the iOS platform team. And I want to pick up where Cary has finished with a focus on one particular area on modals and presenting custom modal content. So sometimes you need to present a modal to interrupt the UX flow on a side check or something that's important that requires the user's attention. And Swift UI only gives you very limited tool set. So it gives you alerts, action sheets, and full screen covers. But the problem is that these are not flexible. They don't allow you to have a flexible content size, and some of them cannot really be customized at all. Next slide, please. However, some of our UX designs actually have bottom sheets, toast alerts, tooltips that are also modal content, but you have no built-in APIs to support these. So in order to utilize them, you have to build them from scratch. And you actually need support for these in a convenient way before you can start writing an entirely Swift UI-based application. Otherwise, you always have to go back to UIKit when trying to support these. So with this mindset, I like to go through this 3-step iteration that we have done in the past to come up with some kind of support for this problem. So the first iteration was with an admittedly novel understanding of the Swift UI framework. What we did, we used a tandem solution with a preference key and an overlay preference on a root view. So the preference key transported the view information that you want to present as a modal. And the root view specified that where in the view hierarchy should this overlay appear to cover the full screen. And while it works nicely in a test application, it doesn't work in the real application. And the reason for that is the DoorDash application is still a hybrid application between UIKit and SwiftUI. That little root tab bar on the bottom of the screen is still UIKit. And so the content in one of the tabs has no way to present an overlay that would cover that root tab bar. So this solution required an anchor, which is a kind of shortcoming. It doesn't work with hybrid applications. And when going through it, the preference keys were really unreliable when you wanted to provide smooth animations. So with this in mind, we had to go back to the drawing board. Next slide, please. On the second iteration, we tried to solve the clipping issue, that we needed something as a modal content that can take control of the entire screen real estate. So we replaced the overlay preference with UIKit modal presentation behind the scenes. So we still required a parent view that smuggled in a view controller into the view hierarchy that was completely transparent and not used other than being a basis for modal presentation. So this solution still relied on preference keys to transport the content you want to present, but the presentation took place using UIKit APIs on this transparent UIKit view controller. And the results were actually quite convincing. So if you go to the next slide, you can see there is this nice bottom sheet that now is visible on top of any kind of foreground elements. So this solution is good enough to be released in production, and many bottom sheets and tooltips and toast alerts you see in the DoorDash application today is actually using this technique to present custom-sized content in a modal sheet or a modal toast or whatever. So this one works with hybrid applications. It works with SwiftUI applications, but it still required a dummy view controller somewhere in the view hierarchy that you need to place before you try to present anything. And it completely ignores SwiftUI animations and transitions, and it only uses the isAnimated flag from the UIKit APIs. It is also a very complicated solution. It has a lot of moving parts, and it made the solution very frail and complicated. And the transition was always cross-vertical, so it always comes from the bottom up. So in our last iteration, we tried to answer two questions. Do we still require a kind of root view or parent view to have a basis for the presentation, and whether or not we can enable the SwiftUI transitions and animations? And as it turns out, with some investigation and some effort, both answers to these questions that yes, it's possible. So our latest iteration that we are trying to adopt gradually is that we only add this view controller or to the screen on demand when a presentation is requested from one of the child views. We present a transparent full screen canvas without animation, but using the UIKit APIs, and then we let SwiftUI to animate its own content onto this canvas that we have now available. So this solution works with UIKit applications, SwiftUI applications. It does honor the transitions, and it no longer requires any kind of root use. So it's a self-contained solution on the API level. And I've created a small little test application, and you can see the results of it in this slide. So the difference between these four use cases is the content that you present specify different SwiftUI transitions, how the content should appear. And so this solution is actually good enough because you can use an entirely SwiftUI-based API, animations and transitions, but the content is still modal and cover the entire screen just like you want it to. If you have any questions about it, let me know. And now let me hand it off to Michael to talk about a different kind of transition.
Hello, everyone. I'm Michael Thole. I'm a software engineer, also on the iOS platform team with Zoltan. Yeah, we wanted to talk about our experience transitioning the entire team to M1 chips over the last few months. Big question is, why bother with that? The answer is that software development includes a lot of waiting for the compiler because compiling is slow. Everyone's favorite KCD here. It's not just slow, it also interrupts your workflow. It can be frustrating. I certainly do not like waiting for my tools. I enjoy my fair share of coffee breaks, but I'd rather them, be my choice, not constantly waiting on my computer. So there's lots of ways to approach this problem, and we've talked about a few of them, but one big one here is upgrading our machines to these super amazing new chips from Apple. At the risk of sounding like an Apple commercial, they're great. Let's go to the next slide, and you can actually see our early measurements that we took in order to kind of make a case for upgrading the whole team. Long story short is comparing a 2019 top of the spec MacBook Pro with a 2021 M1 Max, our compile time is almost exactly cut in half, which is pretty phenomenal. It's not really, something that you'll see happen very much, at least in my experience. Hardware upgrades are much more incremental. So this is kind of a special, extra big upgrade. And so you should definitely get them if you haven't. Just to tell a quick little background about how we were able to make a case to get these upgraded, and how you can too, is with just very basic math. So next slide. So what is this? The graph here is showing the time spent basically waiting on your computer to compile. And so that teal line starts at 0 because it's using your existing already paid for laptop, and it has a slope. And so every day you spend, whatever time period waiting on your computer, and that goes up with that degree of slope. And then the red line starts up higher because there's a $3,000 or $4,000 cost to upgrading the machine, but its slope is less. And at some point, those two lines will cross. That's your payback period. For us, we calculated this out to be somewhere around the 40-day mark, which makes this a bit of a no-brainer from kind of a budgeting return on investment perspective. So we were able to very quickly make the case to get everybody upgraded. We spent most of our time actually just waiting on like supply chain issues and that kind of stuff, but we're now at 100% M1, which has been great. We're super happy with it, but it's not all been perfect. So a couple of things in particular that have been problematic that thought we would share. So first is Google Maps. Both of our apps use Google Maps extensively, but at least in our experience, the M1 simulator architecture is not well supported. And this also kind of overlaps with Swift Package Manager support, or the lack thereof, with Google Maps currently. So we've had to kind of repackage some things to get it to work with Swift Package Manager, which we use for everything else. And so those two things together kind of resulted in us basically having to opt out of using Google Maps in the simulator at all. So instead of this nice interactive Google Maps, you just get this sad little view on the next slide that just says, oh, hey, sorry, Google Maps don't work here. If anybody from Google is around and wants to talk about this afterward, happy to pick your brain about this. So next problem we've run into is snapshot tests. So if you're not familiar with snapshot tests, it's basically you configure a view, you take a snapshot of it, and you compare it to what you expect it to look like. And it's a pixel by pixel exact image comparison. And when we upgraded to the M1 chips, we started adding new new snapshot tests, and they started failing. On the next slide, you can see a comparison between two of these tests. They look exactly the same to me and to every other human, but they are ever so slightly different, different enough to fail our snapshot tests. There's a few different ways of fixing this. We ended up fixing it just by lowering our precision to 99% from 100%. Hopefully we can eventually upgrade our CI to also be M1, and then we can get rid of that and go back to 100%. Yeah, so that's basically it. TLDR, if you're doing a non-trivial project, you should totally be upgrading to M1 Workstation, get your boss, your company, whatever, to get them for you. Totally worth it in our experience. And so next up, we will have my colleague Dylan tell us about one more favorite thing of mine, which is modularizing our code base.
All right, thanks, Michael. And I hope everybody can hear me. Yes, Cary, can you hear me? I can see you on video. Cool. All right. So yeah, today I'm going to be talking about how we modularized our consumer code base. So my name is Dylan. I've been on the iOS platform team here at DoorDash for about a year now. Yeah, and also work with Zoltan and Michael directly and get to listen to Cary's memes frequently. Yeah, so next slide. So yeah, briefly retouching on why you modularize a code base, and the most common thing you often hear is reducing build times, and that's absolutely true because you're building and rebuilding a smaller subset of the code. But another big one you don't hear as often is creating explicit code boundaries. So modularization combined with some dependency tree rules can make it easier to see the potential impact of code changes at a glance, and we'll talk more about that here in the next few slides. Yeah, so diving right in. So it's a big topic. So I'm going to start with kind of a legend here. So we have A pointing at B, these squircles. So in this case, that means A depends on B. So looking at this right, or the left side here, this is kind of where we started. One big module. And in our case, it had a modules directory with a bunch of experiences as subdirectories. You know, kind of the common thing you see in codebase is pattern matching, like I'm going to add a new thing, or other things that look like mine from a folder perspective. So in this first pass, we're going to take each of those subdirectories and convert them to proper build targets, as you see here on the right. And this bottom module is kind of the code remaining in this now shared space as we extract experiences. Some more details on that process. So as experiences are extracted, you may find that this shared module, some of the symbols in it need to go from internal to public, because internal is the default access control, just so these experiences can see them. When moving an experience out, you may notice that a different experience needs it. In that case, just move that code back, because this isn't a refactoring pass. This is purely a code moving pass for various reasons. And kind of related to that, we decided that experiences cannot depend on each other to avoid circular dependencies. So the results of the first pass. So we went from 1 module to 53. I guess it would be 54, adding in that shared module. And just kind of somewhat random SwiftUI preview from clean, the build time went from 241.7 seconds to 110.7 seconds to build that preview. So kind of crazy, right? A few extra things I noticed during this first modularization pass. So I noticed we spent a lot of time building and rebuilding our design system dependency. So, you know, my first thought is, you know, why is it so slow? My second thought is, can we just avoid that entirely? And we did that through distributing it as a binary, so more specifically an XC framework. So that previously mentioned SwiftUI preview was further reduced from 110.7 seconds down to 80 seconds. And similarly, our tests were in a giant module as well, our unit tests. So for each of these new experience modules, we created companion test modules that made tests for a particular domain more discoverable and faster to run, because again, we're running fewer tests. So the next step in this process, the kind of the current phase we're in. So this is where we're starting now, assuming that this first pass is done, where all the experiences have been extracted. Now we kind of want to get to the next logical step, which is partitioning kind of the code remaining in the shared space. So this is kind of what you'd maybe expect, just kind of looking at it quickly, but that wasn't quite the case. Next slide. After looking at the code and kind of trying to partition it, we just noticed that all the code wasn't the same. We noticed that we had some domain specific things and some domain agnostic things. So like an example of domain specific would be something like cart service. Domain agnostic would be something like a GraphQL client. And we wanted domain specific to depend on domain agnostic, but not the other way around. And similarly, we had UI and logic building blocks, and we kind of wanted to prevent feature specific code from sneaking into those modules. So the solution here was to add more layers. And these are actually diagrams and tables extracted from the RFC I wrote a while back. So you can kind of see that not only do we add layers that kind of communicate what each of these things are, and I'll talk about the definitions here in a second, but a unidirectional build graph to where you can't kind of mix feature specific and feature agnostic things together. All right, yeah, and here are those definitions. So we called the experiences components in our case, and they were extracted in the first pass that I previously talked about. And then these last four are kind of the shared code that we're partitioning. So domain interface is kind of the public side of a specific domain. So cart interface and store interface being examples. Capabilities are domain agnostic features and functions. So error reporter or mount image, you know, think SDK or dependency wrappers, encapsulating those here, just so you know they don't trickle throughout the code base. And lastly, core UI and core are UI and logic building blocks, where we only allow you know, Apple imports to kind of keep them pure, if you will. Next slide. Yeah, so the partitioning process with that in mind. So an important thing to note here is we can actually leverage the benefits of modularization during this work, which is great. So I have two examples here. Say this teal domain interface we have here on the left. say we extracted that from the old shared module kind of into a new target, created a scheme for it. Now, what would that look like? Again, using the modularization benefits here. So we create the scheme for it, continue to build it until, if we need to change access control or add dependencies or whatever, as soon as it builds, it's just a matter of adding imports higher to the higher layers. So in this case, adding sorry, one more thing there. Adding an import to that component on the top left there. Kind of the same story for the capability. As soon as we get that target and scheme building, it's just a matter of adding imports to the higher layers. So we didn't have any problems, right? We just continue this process until that old shared module is gone. Well, not quite. So depending on the size of your team and the amount of code, code might still be going into that shared module, kind of as you're moving to pull things out. And that's fine for a certain amount of time, but there's a certain point where we need to deprecate that shared module and say, hey, you probably need this type of module. So we added danger to CI at a certain date to say like, hey, I think you need to move this file here. And similarly, we noticed that Swift Package Manager is not super strict about dependencies being represented, and more specifically, transitive dependencies. So we wrote a custom Swift package that goes through and scans the imports for a particular target, and then uses Apple's Swift syntax to write those dependencies to the package manifest. And so here it is in action. So this is a comment on a PR from Danger. So the first comment is when package bot, that's that Swift syntax custom Swift package that I had mentioned, detects imports not represented in package.swift. It says, hey, just run the script and it'll fix it for you. And then the second error is when a new file is added to our shared module after we formally deprecated it. Say, hey, you probably want to put this somewhere else. Here's a link to the RFC. Let us know if you need any help. So here's where we're at today. So this current pass isn't quite done. We started at about 1,000 files and 80,000 lines of code. We're currently at around 50 files and 2,300 lines of code. As you'd imagine, as we approach zero, the need for refactoring and things that I didn't quite anticipate in my initial RFC are starting to pop up more and more. So it's slowed down quite a bit, but it's all good work. And here's where we're at today as far as number of modules. So at the beginning of this presentation, started at 1, now at 155. So with that, hopefully you learned a little bit there. I'm going to be passing it over to Tom, who's going to be talking about building CI and CD in iOS. Thanks.
Hey everyone, my name's Tom. I'm an iOS developer on the iOS platform team. Also, I've been here at DoorDash for about 5.5 years. And I'm going to talk about some of the kind of problems we ran into with CI and CD as we scaled and had the different kind of applications and frameworks and things like that. As well as some solutions we took and things to kind of make our lives easier as well. So first off, like we kind of use Fastlane scripts. They're a set of kind of build scripts that kind of can make your life easier, but we were relying on them for more and more functions, kind of having that be the cornerstone of like our logic for different things, but between the different applications, frameworks, things like that, they started to kind of deviate a fair amount too. And on the next slide, another problem we kind of ran about is, our CI/CD, which we use Bitrise behind the scenes. We kind of had no consistency between the different applications. So we kind of, we're starting to have different kind of builds, different processes on the different apps or frameworks. So we wanted to kind of unify that together as well. So some of our solutions was, we kind of used what's available with Fastlane to use a single kind of Fastlane script that's kind of hosted separately to manage all of our different applications, frameworks, so that everything's kind of, there's a single source of truth, everything's working on that. This kind of allowed us to easily spin up new functionality and then automatically get it across all our different, projects or repos. And if a new project, spins up or someone wants to test something, we can get it on CI super quick. We use environmental files that we kind of, inject to differentiate the app's targets, all that stuff. And it keeps our like Bitrise implementation a lot more simple too. So we're not like using all these kind of logic and steps on Bitrise. So kind of the global Fastlane repo, like I mentioned, we do a bunch of stuff kind of using Fastlane at this point. We're individually running tests. We're, signing the app and managing that. We're kind of, as far as signing, we're managing running on devices, like creating certificates, using Match, all their good stuff that they have kind of built in there, as well as like test flight and app store builds, that we want like people to easily be able to kick off. And then we have like nightly releases that also are released to, internal kind of employees on a regular cadence, so they can kind of, dog food our app, if you will. With that, being able to kind of have this global file that gives us all that functionality, we needed to obviously differentiate between the applications. We chose just like an environmental file to kind of inject into this. It just kind of made life easy, and we were able to like templatize it for new, kind of repositories and things like that. So each, project has its own M file, and it uses the Fastlane individual scripts use the import from Git, which is a Fastlane command also to actually pull that lane from the repository. So for instance, like basically your Fastlane on each project is pretty simple. It's just, application specific stuff, and then this import from Git, and then you can use the commands, inject in the environment variable to any project, kind of making it pretty simple. And then the same kind of commands using Fastlane across apps, and then also CI the same kind of across apps as well. Why we kind of use Bitrise, it kind of gives us a large list of benefits in kind of managing virtual machines. And then with pairing it with Fastlane, it kind of allows us to keep, CI implementation minimal. If we decide, we want to bring it in-house or, change provider in the future, like with Fastlane, it will be pretty, kind of simple from that point of view. But for right now, as far as how many builds we're doing, managing those builds, doing it, possibly across different versions of Xcode when new versions come out, Bitrise kind of makes that a lot simpler for us. And then kind of some functionality we're able to do with Bitrise, which is pretty nice, kind of using the Fastlane script as well, is, we can kind of simplify some of our tasks that we were doing manually. So obviously with a team our size, not everyone has full access to, all our systems. So for instance, like our Apple developer accounts kind of, restricted, but we still want developers to easily be able to, add an iPhone. So we kind of created, a workflow that fires off the registered devices kind of flow in Fastlane, which then, just by parsing the kind of Bitrise message, we're able to quickly add kind of devices, let users do that themselves, recreate the provisioning profiles when that happens, and kind of all in all, like just making, things kind of simpler in general there. So I think with that kind of being said, I think, kind of using Fastlane across the repos and just having a single source of truth, has a big advantage to just kind of speeding up things and making things continuous between the different applications. Thank you.
All right. Well, thank you very much, Tom, and all the other presenters for sharing our learnings at DoorDash. With that, I would like to open it up for panelist discussion. So in addition to the presenters that we had today, we have three iOS engineers who joined us for this event. So I would like to introduce them and also ask like icebreaker question to each one of them. So let's get started with Laura. Could you please introduce yourself and tell us some of your favorite things about working at DoorDash?
Yeah, sounds good. Hi, everyone. My name is Laura. I've been at DoorDash for about 3.5 years, close to 4 years at this point. I'm a tech lead in the logistics organization, and I've been primarily focused on the Dasher experience and the Dasher team. Up until earlier this year, I was specifically working on ensuring that Dashers are navigated to the right spot to fulfill their deliveries and be successful in the platform and efficiently drop off the order and move on to the next delivery. Right now, I'm more focused on the overall experience of providing Dashers the right set of opportunities for their own schedule and enabling them to earn in the way that they want to earn with certain preferences. I think it's certainly tough to answer, like, what are favorite things at DoorDash? I think there's so many. This is something that I certainly get asked a lot in interviews. And but I think my answer is pretty consistent. It has been pretty consistent that my number one thing is certainly the people. As you've heard today, there's a lot of sharp engineers, and not just sharp, but amazing collaborators, amazing folks that want to just knowledge share, that want to like mentor and bring up everybody else. We have monthly meetings with all of the iOS team to discuss iOS designs, to discuss things and make sure that everybody in the team can actually knowledge share. So that's certainly my number one, but I also want to also mention that even though DoorDash has been a company for many years, in many ways, we're still in like day zero, day one of our journey. There's so much opportunities in the space. And so what really excites me is the ability to continue to impact across all of our audiences, consumers, merchants, and Dashers. There's a strong ability to wear multiple hats in this company. And I've learned so much from a business perspective and from a priority perspective, figuring out like what are the right things to work on to just provide an overall excellent experience in the platform. So those are some of my thoughts.
Oh, awesome. Thank you, Laura. I definitely second that on the people side of things. In fact, everyone on this loop were all volunteers who wanted to share their experience here and what they learned. So yeah, awesome. All right, next up, we have Joshua. Can you share what you do at DoorDash and maybe your most exciting project that you worked on here?
Yeah, hi everyone, I'm Joshua. Been at DoorDash now for almost a year and a half. How time just flies. I started actually on the Dasher side as well, on the driver app. And actually just recently switched over to consumer, working on growth actually, so on acquisition. So for example, like guest flow is an example of a project there. One of the most exciting projects that I worked on here at DoorDash was Safe Dash. Maybe you all saw this publicly announced or not. But what it was is that we integrated with a third-party vendor, which was ADT, to provide a safety toolkit within the Dasher app, the driver app, so that Dashers could feel safe while they're dashing. And so the safety toolkit provides two options where they can actually request emergency services in case of any incident, or they can actually request to talk to an ADT agent while on a dash so they can feel safer. And I think for me, what was exciting was it was kind of an ambiguous problem. Like, how do you make Dashers feel safe? And then also the impact that it has. Like, this is a very, it's a little bit different from like, GMV or, increasing users or anything like that. It was making Dashers feel safe. So I really love that type of impact on people and their everyday job. So, yeah.
Awesome. Thank you, Joshua. Yeah, I normally work on the consumer side, so I didn't even know what kind of project was on the Dasher side, but it's pretty cool what you're able to do there. And also transitioning from the Dasher side to the consumer side. We do encourage a lot of people at DoorDash to try out different things. In fact, a lot of the framework and fundamental things are really shared across apps so that it's easier for people like Joshua who wants to transition from one place to another easily. So, all right. And last but not least, Alice, who's actually on my team. Why don't you tell us a little bit about yourself and also about how we prioritize large engineering-driven initiatives like a Swift UI migration or server-driven UI that we do at DoorDash? How do we coordinate with product teams on those projects?
Yeah. Hi, everyone. I'm Alice. I'm an iOS engineer here, obviously. I've been here for about 3 years now, which is pretty crazy to think about. But yeah, in my time here, I've been on consumer the entire time. I started out on a product team. I worked a lot on the homepage and the search page. And I'm currently actually on a client platform team. So yeah, regarding technical engineering driven initiatives, those can get very tricky, especially for initiatives that span the entire code base, especially because at DoorDash, we have so many different product teams. So the way that we're organized is that each product team has an area of component ownership. So when a platform team wants to affect the entire code base like this, we have to involve a TPM at least, and a data scientist usually, to make sure we're not regressing on any of our current features, because there are just so many throughout our app. And we found that it works best when the platform engineers work in very close partnership with the component owners, because they're the ones who understand their feature the best. And yeah, that's basically how we do it.
Awesome. Thank you very much, Alice. All right, with that, I will open it up to Q&A. So I've been looking at the Q&A on Zoom, and it seems like there are close to 90 questions, and we answered a good chunk, 68 of them right now. But I think some of them, maybe it's worth deep diving and answering in live as well. So I'll be asking, let me select some of these questions. So maybe the first one, since we did talk a lot about Swift UI, maybe to Cary, could you go over how you manage the hurdle of working with both UI Kit and Swift UI for people who's considering transitioning to Swift UI?
Sure. Yeah, I can do that live real quick. So there were a lot of challenges, but not so much on the UI side of things. Just remember, you're always welcome to fall back to UIKit if need be. One of the biggest challenges that we ran into didn't have a lot to do with the UI, but it was synchronizing app states for things that were, for an application that was sometimes in SwiftUI, but the remainder bits were not in SwiftUI just yet. So we had to figure out a creative solution to synchronize the state for that particular feature so that it would persist in the application memory the whole time. I don't know how much I'm allowed to disclose here, but just think of it as like a caching mechanism that lives throughout the duration of the application session.
Sounds good. Thank you, Cary. We also had a lot of question around interview process. So I think an interview process might be different slightly depending on the team. But Alice, would you like to share a little bit about how we do interview here?
Yeah, happy to. So yeah, someone asked where they can find it. I don't think we list it publicly, but once you start the process, our recruiters are super helpful in telling you exactly what the process is going to be. But just to give everyone here a high-level overview, it starts out with a technical phone screen. That's an hour, and you get 45 minutes to do basically a simple network download and deserializing that data and using that to populate a simple-ish UI. And then beyond that, there is our virtual onsite, which takes about 4 to 5 hours. And that includes, I believe, 5 different modules. There's debugging, architecture, project coding, and eng values. Am I missing anything? That actually might be it. So yeah, those are the 4 different modules that you would do on the onsite. And those are, I believe they're all done virtually. So you can actually split it up into 2 days as well.
Awesome. Thank you, Alice. One thing to note is that we're constantly evolving our interview process as well. So that might be true today, but of course, in a month, it might be different. So make sure to check in with your interview coordinator and recruiter to get the latest. All right, next up, let's take maybe the organizational one. So Michael, what is the biggest growing pain point when adding 40 plus dev over a year?
Great question. I don't have a prepared answer, but I think it basically comes down to communication of different types. So organizationally, there isn't one big iOS team with 90 engineers on it. We've got couple dozen feature teams where, there's 1 or 2 iOS engineers, 1 or 2 backend engineers, 1 or 2 Android engineers, a PM designer, and they're a unit working on a feature. Like you might own gift cards or you might own the checkout process. And so that's the primary team. And there's kind of this different horizontal slice of all the iOS engineers working together in the same code base. And so it's bit of an informal communication mechanism. So as you're changing things in the iOS world, that's going to affect all these other teams. We don't have a super great way of consistently and officially, having those types of communications. So it's a lot of just like Slack. We have a few like monthly meetups and like a weekly stand up, but only certain people attend, etc. So that's been a challenge. We're still working through it. We do a bunch of like Slack support stuff. Like our team, the platform team, has an Ask iOS platform channel now, and so we field a lot of questions there. And when we get duplicate questions, we can point people back to previous ones. So we're iterating and learning, but it's definitely a good problem to have. So we'd like to hire more of you.
Awesome, thank you, Michael. All right, let's take on another Swift UI question. So this one for Zoltan, what Swift UI for iOS 13, was Swift UI for iOS 13 enough? Or did you find that it was better only to use it if a newer version than 13 is used?
So iOS 13 was definitely not enough. If you want to go with iOS 13 support, you need to go at least iOS 13.3. So the previous 3 minor versions, the 0.0, 1.2 were simply unusable. It randomly crashed on very arbitrary scenarios. That was a big headache for us. So we actually had to delay shipping anything until our user base really dropped those early versions of iOS 13. From iOS 13 on, iOS 13.3 on, you can actually use it pretty reliably. There will be always minor differences between these major versions, like how does an animation work? Is it really smooth enough? Or sometimes you have odd bugs that are difficult to explain and they only surface on earlier versions of Swift UI. Eventually, we just decided that it's easier to go with iOS 14 and later versions and drop all the headache that comes with iOS 13.
Awesome, thank you. I've been part of multiple issues with the older versions as well. So awesome. All right, 1 minute left. Last question. This one is for Dylan. How do you avoid redundancy and duplicate code across all those modules?
Yeah, that's a great question. So my general advice when adding code is to kind of add it at the highest layer first. So say if you're working on a particular feature, kind of put the code there first before trying to put it in a general space and make it general. So I guess part of the answer is communication. Like, hey, has anybody made this? Because Swift UI does have some quirks, and when we fix them in one place, we kind of want the same fix everywhere. Other than that, there's tooling, right? So I mentioned this thing, PackageBot, that we created that makes sure that dependencies are represented in package.swift, but we also want the reverse, that when we delete code and we no longer need a dependency, that code gets cleaned out. So in that case, we delete the code, but the import's still hanging there and we're still getting the build time hit. In that case, we use SwiftLens analyze functionality to kind of remove unused declarations. So yeah, I hope that answers the question.
Cool. Awesome. Thank you, Dylan. All right, we are right on the time. Right on time. So with that, I would like to conclude today's presentation. Thank you all the presenters and the panelists for joining, as well as all the people who came and joined. There's 200 of you today, so that was great. Yeah, and if you're interested in applying to DoorDash, it's careers.doordash.com. So hopefully some of you guys learned a lot from this presentation, and maybe we'll see you at DoorDash. Thank you.